So what we're going to do is we're going to take and we're going to talk about what happens if you know information about the angle alpha, you know information about the angle beta, and then you want to know what would happen if you had the sine of the two angles added together, or what would happen if you had the cosine of the two angles added together. Okay? And this is where the rules that we gave you on the back of your sheet come in handy. These are where the reference triangles come from. All right? Now, you've got the problem written down, even though you thought I wasn't going to teach. You've got the problem written down. I'm going to erase these and just find them one at a time. We'll show you how to do it. Okay? So we'll find this one first, and we'll find this one. And if you don't have them all written down, that's okay. Just have that, and I'll show you how to find different parts. All right? Now, when you do these, there is a certain pattern you want to follow. You want to write two separate reference triangles. You want to write the reference triangle for the alpha, and you want to write the reference triangle for the beta. Do not try to put both reference triangles on the same graph. It will mess you up. Quadrant 4. Okay, -3, 5, 4, and then label that as your alpha. Okay, and opposite over hypotenuse, and then this side is 4. If you don't put it in the right quadrant, you end up getting numbers wrong. Then when you do your beta one, we're going to put it in quadrant 3. And I went ahead and made these to where the quadrants weren't just quadrant 1 and 2. The first ones you do in the book, quadrant 1 and 2, but you won't learn it that way very well. Beta, 7/24. Very good. That has to be negative, that has to be negative, and the hypotenuse is always positive. That's the reason you got to know your triangles. That's why you've got to draw your reference triangles correctly. If you get your reference triangles correctly, then you simply look on the back of your sheet and you use the rule. And let's just make sure everyone's okay with the two reference triangles. Yes, sir?
On the, not that one, but the first one, why is the 5 the hypotenuse? Wouldn't it be the other way?
You always use opposite over hypotenuse.
Okay. Oh, because it's okay, I see. Okay.
There you go. Now, yeah, sine is opposite over hypotenuse. And if you draw the triangle wrong, life's about to get bad. Okay. Now, we want to do sine of alpha plus beta. So we look on our rule, and our rule says that that is the sine of alpha, cosine of beta, plus the sine of beta, cosine of alpha. All right? That's a rule. I gave you that rule. Make sure you got it on the back of your sheet, right? Everybody's looking at it on the back of their circle. Make sure you got that. It's under the sum and difference rule. Because you've got to have that rule. It's sine A, cosine B, plus sine B, cosine A. Now, some teachers will change the order of these right here. That's okay, but I can memorize it better this way. So then, all I do is I look for the sine of alpha. What is the sine of alpha? -3/5. Somebody says, well, you already knew that without drawing the triangle. Yeah, you did. Then I look for the cosine of beta. -24/25. Plus, then I look for the sine of beta. And then I look for the cosine of alpha. 4 what? 5ths. Is that okay? 4/5. Now, here's the magical moment. Make sure you know how to get all those numbers. Everybody okay with getting all those numbers? When you multiply them together, you're always going to get a common denominator if you do it right. If you're not getting common denominators down here, you're not doing it right. Okay, 72 over 125 plus -28 over 125, add those together, that's 450, 44. 44 over 125. Yeah, and there you go. That's what the sine of alpha plus beta would be. If you draw the triangles right and you substitute into the formula right and you got the right formula, it's not hard because they always going to have a common denominator. Okay, yes ma'am.
I was just saying, like, all the letters and stuff makes it look hard. But like,
It's not.
It's
If
not
you just,
hard.
It's not. The problem students have is if you put that in the wrong quadrant, that sign will be wrong. And if that negative is wrong, that negative is going to be wrong, and then boom, everything's wrong. Okay? Let's go ahead and do cosine A plus B just because it'll be good practice, and I'll show you a little trick. Cosine alpha plus beta. The rule for cosine of alpha plus beta is cosine alpha, cosine beta, minus sine alpha, sine beta. And it is a minus sign right there. It is. And if you were taking this class in college right now, your professor would probably prove that this really does turn into that. Okay? They would do the proof to show you this formula is really right. Mr. Evans could do the proof if his life depended on it, or he might do the proof if he was going to get steak dinner, you know. But otherwise, he's not doing the proof. All right? Now, the cosine of alpha, 4/5. And somebody will tell you there's another way to do this. I'm wanting you to learn the rules, so we're going to do that. Cosine beta, negative 24 over 25. Minus sine of alpha, that's negative 3 over 5. Cosine of beta, negative 7 over 25. Now, there's negative 96 over 125 minus, and that negative times that negative is going to make a what? Positive. And so you'll get negative 117 over 125. So you got the both negative. Now, here's the cool thing. But I'm going to let you write that and make sure you're okay. Make sure everyone's okay. So far, so good. If you square this number and you square this number, you add them together, you will get 1. Because sine squared of all that plus cosine squared of the same thing always has to equal what? 1. So if you ever want to check to see if your two answers are right, square that one, add them together, see if you get 1. And you will. Okay? And that's how you get them. Now, let me show you my trick that people that are listening will know about, people that aren't won't. All right. If you ask me what the tangent of alpha plus beta is, I'm going to erase this for just a second because I'm going to put it right up here. This is a biggie. This is one of those things I'm going to save you some pain and agony on. You got two options. If I was having to find this, and I did not have to find anything else, I would use the formula that's on the back of your page. But I'm not going to use that formula because I know that that equals what? Sine over what? And guess what? You've already worked those out, haven't you? Sine 44 over 125. Cosine negative 117 over 125, and that reduces to negative 44 over 117. Multiply the top and bottom of the fraction by 125, and then move the negative sign up. So finding tangents pretty easy to do if you've already found cosine and sine. All right? Now, if you want to know secant or cosecant, all you got to do is do what? Take reciprocals. That's the reason I didn't give you any formulas for secant alpha plus beta. Find the cosine, take the what? Reciprocal. But these are cool because they, it's serious trick, and it scares you to death. But like you said, if you realize, if you write the formula out and substitute into it and don't panic, it's doable.
Pretty easy.
Okay, pretty easy. Are we happy so far? Draw the triangles. Now, this is a type I like, but I'm going to show you the other application of this. Here we go. I have the angle of 105 degrees. I want to know the sine of 105 degrees, and I want to know the exact value. Exact value. Probably shouldn't have done 105, but it's okay. Well, what you have to do is find two angles on your unit circle that will add up to 105 or subtract and get 105. So what would you do? Look at your unit circle and tell me what would you add together to get 105? And there's several answers you could use.
60 and 45.
60 and 45. Is that okay? 60 and 45. All right. Sine of 60 degrees plus what? That is your alpha and that is your beta. See how that fits? What you're doing is you're turning it into two angles that you know. 60 and 45. Now, that's why if you have your unit circle angles, you can start actually figuring out whole bunches of angles. Because you can use these rules and anything that you can, like 15. If you wanted to do 15, you would have done 60 plus 45, you'd have done what? 60 minus 45. Or you could have done what? 45 minus 30, and it would have still worked. All right? These are pretty cool. Now, that's going to be sine of alpha, cosine of beta, plus sine of beta, cosine of alpha, sine alpha, sine of 60 degrees. I'm going to go ahead and write them in. I'm not going to try to do it in my head. Cosine 45 plus sine 45, cosine of 60. And how are you going to get the values that those are? You're just going to look on your what? Unit circle. So these rules work whether you're talking about unit circle angles that you put together or reference triangles. And then the sine of 60 is square root of 3 over 2, 1 over the square root of 2, 1 over square root of 2. And the cosine of 60 is 1/2. And so you get square root of 3 plus 1 over 2 square root of 2. And I think it's the coolest thing in the world that you always get a common denominator. I mean, that to me, because if I was a student and I saw these kind of looking things, I'd think, oh God. But then their common denominator is good. Now, if you look in the back of the book, they'll have square root of 6 plus square root of 2 over 4. Because they're going to rationalize it. They're going to multiply the numerator and denominator by what? Square root of 2. But that's how you handle it if they're asking for exact values of angles. Now, there's more rules, but for right now we're sticking to A plus B, A minus B, or 2 times A. Okay? There's rules for half of the angle, there's rules, all kinds of rules, but here's the catch. If you can do these, and I give you the rules for the other ones, you can do them too. All right? So if you learn how to do these are the hardest ones right here. A plus B and A minus B. The other formulas, the problem is just memorizing. Okay? Don't write this down. The sine squared of theta equals 1/2 1 minus cosine of 2 thetas. That is a formula you will never use unless you're taking Calc 2. That's a trig identity that's only reserved for integral calculus. You don't use it for anything else. But if you're taking, they'll have a little integral sign, integral calculus. Matter of fact, I'll go ahead and write both of them down and you can put them on the back of your page. And you only use them, they don't come in handy for anything we're doing, they don't come in handy for anything out there right now, but they come in real handy for one part of calculus. And just put them on the back of your page, and if you take Calc 2 in college, your professor's going to start scribbling them on the board. And the problem is he doesn't tell you he's doing it. What'll happen is you'll be sitting there in class and he'll write this. That means the integral of, and then underneath it he'll just put, and he doesn't tell you how you got there. That's an identity. From here to here is an identity, and you're going to see it in Calc 2. All right? And that's one that's not probably even in the, it's probably not in the high school textbook. And if it is in the college textbook, you'll never use it in the textbook, so, you know, you may never see it. But I promise you, when you get off to the world calculus, you'll end up using it. There's several trig identities that I don't use because I just don't need them. Here we go. We'll do one more little bit. This is a, okay, if you're in physics, they will use identities to do what I'm about to do. But you're not in there, so let me show you something. Let's say I had the cosine of 90 degrees plus the angle. And I don't want that. I don't like having 90 degrees added to whatever angle they tell me. In other words, if they tell me the angle's 20 degrees, I'd have to do what? 90 plus 20. If they tell me the angle's 60, I'd have to do 90 plus 60. That just looks messy. Well, in your physics book, they just have equals to, and they tell you what it equals. I'm going to show you how they get that in your physics book. You probably know. That's what? Alpha plus what? So you do cosine of 90, cosine of theta, minus sine of 90, sine of theta. And the wonderful thing about this is, what is the cosine of 90 degrees on your unit circle? 0. So 0 times cosine theta minus, what's the sine of 90 degrees? 1. Sine theta. So that becomes 0, and you get negative sine theta. So instead of having to work that in physics, what is your physics teacher going to change it into? Negative sine theta. Here's the problem. They don't do these steps. They just memorize them. They know them for sine and cosine of 90 plus and 180 plus. Okay? And they just memorize the rules. And I'll give you those identities later. I won't work them all out, but that's how you work them out to prove them. But if you look at a physics book, they'll tell you that equals negative sine theta. All right? Now, I'm going to give you one I want you to put stars by, and I want you to put this one on the back of your page. I want these two on the back of your page, on the back of your circle, right? I'm going to give you some to put stars by. These are little specialties. These make life easier. The cosine of a negative angle is equal to the same thing as the cosine of the positive angle. The cosine of negative 15 and the cosine of 15 are exactly the same thing. Look on your unit circle. If you go from the 0 point and go down, or you go up, do you notice you get the same cosine values? Is that okay? Yeah. So whether you're doing cosine of negative angles or cosine of positive angles, you get the same answers. So when you look at textbooks, if they ever have cosine of negative 45, the next step will have cosine of positive 45. Because do you really want to deal with a negative angle? Okay? So I never do cosines of negatives because I know that rule. The sines of negative angles is not the same rule. It will equal the negative of the sine of the positive angle. Okay, look on your circle. Look on your circle. If you're going this way, you're talking about a negative angle. If you're going this way, you're talking about a positive angle. Sine value right here, 1/2 comma square root of 3 over 2. And what happens down here? 1/2 comma what? So if I ever have to do the sine of a negative angle, I just put negative sine of the positive. You are not factoring that negative sign out. Because if you do that, then this would have to have a negative, right? They're just trig rules. The cosine of a negative angle equals the same thing as the cosine of a positive angle. The sine of a negative angle, if you don't want to do negative angles, make it a sine of a positive angle and put the negative sign where? Out front. Those two rules save you having to deal with negative angles. And those are two I meant to tell y'all the other day and I forget. These are, you see these in calculus a lot because somebody will work a problem in calculus and they get the cosine of negative 15 and they look in the back of the book and it says cosine of positive 15. And they're freaked out. It's okay. Well, they are what? All right? That's it for today. I've taught you how to use the formulas. I've taught you how, if you know the formulas, it's not hard. I'll give you some information to put on the back of your circle.
Should we put the interval?